Today we're going to solve an 8th grade practice problem that comes from the PARCC. Which expression is equivalent to 7 to the 3rd, which is raised to the 5th, times 7 to the 4th? This is an exponent problem because, as you can see, we have exponents involved in the problem. This is considered a multi-select problem in that there are several choices, and each of the choices will give you a result that either matches the original expression or they will not match the original expression. The multi-select problems tell you that you're likely to get more than one answer. So let's begin. In the first part of this expression, we have what we call two exponents that are sort of connected. One is being raised to the other. We call that power to power. So one exponent or one power is being raised to another power. So we use an exponent rule that says when an exponent is raised to another exponent, we multiply the exponents together. So in this case, we would multiply 3 and 5 and would get 15. So then we would have our base, which is 7, and that remains the same, but our exponent will then become 15. 7 to the 15th then matches the expression 7 to the 3rd raised to the 5th, the exponent. These match as a result. So then I'm going to bring down the rest of the expression. Now we have another rule. We have another power rule that says when you have multiplication or you have the product of two bases that are the same, and these are our bases, and these bases are the same, so we call them like bases. When you have like bases, when multiplying like bases, we can add the exponents. So in this case, we're going to add 15 and 4, and we get 19 as a result. So our final answer is 7 to the 19. So now that I know that this expression, when simplified, is 7 to the 19, I can now go to the choices and see which of the choices represent 7 to the 19. So in part A, we have 7, which is being raised to the 3 times 5 times 4, where we have this exponent is being expanded. So because it's expanded, I know that I'm going to have to simplify that by multiplying 3, 5, and 4. So I have 3 times 5, which is 15, and 15 times 4, which is 60. So then we have our base, which remains a 7, and our exponent becomes 60. When we look at this example, this answer choice, we realize that the answers don't match, which means that we can eliminate A as an answer. Let's look at B. B, we have 7 is being raised to the 3 times 5 plus 4. In this case, we would use the order of operations. And in this case, using the order of operations require us to multiply before we add. So we multiply 3 by 5 and we get 15, and 15 plus 4 is 19. So that gives us a result of 7 to the 19th, which matches our original answer. So we know B is a choice. So let's look at C. C is now 7, which is being raised to the 3 plus 5 plus 4. So this is our exponent expanded. So we have 3 plus 5, which is 8. 8 plus 4 is 12. Therefore, the result is 7 to the 12th. Doesn't match because it's not 7 to the 19th, so we're going to eliminate this choice as well. Let's look at D. D, we have 3 times the sum of 5 and 4. In this case, we can use either the distributive property, where we end up multiplying 3 by 5, and then 3 times 4. Because the distributive property tells me I'm going to distribute the 3, we would get 15, because 3 times 5 is 15, plus we would have 3 times 4, which is 12, and that would give us 27. That's one way. The other way that we can do this is we can actually use our order of operation, because we know that in our order of operation that P, which stands for parentheses, we can actually combine what's inside the parentheses and then take that and multiply it by 3. So in this case, we'll get 5 plus 4, which is 9, and 9 times 3, which is 27. So either way, we still get an exponent of 27. So our result here is 7 to the 27th. And when we look at the result from this expression, it does not match 7 to the 19th, so we eliminate that as well. Well, let's take a look at the next one. We have 7 is being raised to the 3 times 5 times 7 to the 4. Well, here we have 3 times 5, which is 15. So we have 7 to the 15th times 7 to the 4th, which actually takes us right back to the original expression from earlier when we had power raised to another power. We had 15 as a result, and we added 15 and 4, which is very similar because we used the product rule here and added 15 and 4. So very similar. We're going to go back here. We're going to add 15 and 4, and that gives us 19. So here we have a second match. So we have B and E are both selected as answer choices that are equivalent to our original expression. Let's look at the last one. So in this one, we see that 7 is being raised to the 3 plus 5. Well, 7, we know that's going to remain the same. We have 3 plus 5, which is 8. So we have 7 to the 8 times 7 to the 4. And similar to E and the original expression, whenever we have we use a product rule. So when we see that one base is being multiplied by another base, that's exactly the same. We know that we add the exponents. So in this case, we're going to add 8 and 4. We're going to get 12. So that gives us 7 to the 12th, which clearly is not the same as 7 to the 19th. So we eliminate that choice. So if you're taking a computer version of this exam, you would clearly have to select B and E.